Hi everyone, good evening.
Good evening, ma'am.
Good evening, ma'am.
Good evening, madam.
Yeah, good evening. So today we are having a mock interview session. As I told before, in weekdays we are having the regular sessions, theory and lab session. Every Sunday there will be a mock interview. As it is a first week, we will concentrate mostly on the theory part. Okay, from next week onwards we will start a digital logic design problem solving questions, right? So I will ask you to solve the problems and I will explain you some interview questions how to solve the problems and all on all concepts of digital verilog system verilog that will be continued. Okay, so as of today, I'm going to concentrate on mostly whatever we have discussed in this week. Okay, can anyone revise once till now what concepts we have completed from the starting of the course? Pavitra, can you please go on?
Ma'am, I'm
I will
audible,
ask
ma'am.
the yeah, I will ask the questions everyone one by one. So you just respond. Okay.
Ma'am,
Yeah,
this
Pavitra, go
week
on.
only.
Yeah, from the starting course onwards. This week and last
Mm,
week.
Okay, ma'am. First of all, what is mean by VLSI? First, starting the concept. What is mean VLSI? Then following that, nanometer technology, FPGA.
Pavitra, before that, can you please introduce about yourself? Everyone, please introduce about yourself and start talking.
Okay, ma'am. Myself, Nandini Pavitra. I am from Chennai, Tamil Nadu. This is enough, ma'am.
Okay, fine.
Introduction. Okay, ma'am. Yes, ma'am. The last week, we are covered the introduction of VLSI design flow and front and back end domain architectures, SOC, chip design, and FPGA, nanometer technology, Moore's law, and also last week covered by this concept, and the coming week, the last week, digital design. In this concept, what is digital design and add as like binary, what binary bit, byte, what's the difference, and binary arithmetic concept, and logic gates. What are the what are the universal logic gates? And next, Boolean algebra, number systems, binary number system, octal number system, and hexadecimal number system concept, and following binary arithmetic and Boolean combination and the sequential logic circuit. What are the combination logic circuits? Like adders, subtractors, multiplexers, decoder, and the sequential logic circuits, flip-flops, register, counters concept. Then last day, flip-flops, SR latches concept, SR latch, and the last section, multiplexer concept, and finite state machine concept. Then encoder, decoder concept.
Okay, yeah. So yeah, good. Pavitra, have you written the notes all on all the concepts whatever we discussed?
Yes, ma'am.
Okay, okay, fine. So from first week we have discussed all the fundamentals of VLSI, whatever required for the student to know before starting the course, like what is meant by system on chip design, ASIC, FPGA designs, Moore's law, nanometer technology, CMOS, FinFET, GAFET, fabrication technologies, everything we have discussed. And next week we have discussed on digital electronics, all concept applications, right? So next question is for Manisai. Manisai, can you explain what is the difference between embedded system role, VLSI role, and software engineer role?
Good evening, ma'am. I'm Mansai.
Yeah, good evening.
I'm currently in my third year of engineering. Is this enough, ma'am, for introduction?
Yeah, yeah. Okay.
Ma'am, embedded system means it is the combination of hardware and software which performs a specific task, ma'am. In VLSI, we mainly concentrate on the miniature design of the circuit, and aim to we mainly aim to uh, go greater into that nanometer technology and like increase the number of transistors on a single chip. Uh,
If you want, you can share your screen and you can write and show also the diagrams and all.
I'm, I'm not that.
Okay.
In software, we code the in software. It's more like we ma'am, it's all in software. It's all application based, ma'am. We design some applications through coding. Software is not in a physical form, but in embedded system and VLSI, there are physical form of chips.
Okay, in embedded system, how the physical form chips will be connected? What are the different types of chips we use in embedded systems?
Ma'am, I'm not getting any idea, ma'am. Sorry.
We have discussed, right, what is meant by embedded system software and VLSA, how these are interconnected each other, and what are the major roles.
Yes, ma'am.
Just take 5 minutes time and explain again.
Okay, ma'am.
Ramu, can you explain the same question? What is the difference between embedded systems, VLSA, and software?
Uh, Hello, good evening to all of you. I am Ramu. I completed my graduation in 2022 in electrical and electronics engineer. The difference between the VLSI software engineer and the embedded. In the VLSI, we make the hardware, madam, hardware designs, and in the software, we design the applications or operating system with some code. And whereas in the embedded, we connect the software and the hardware to perform our task and function of the system.
Okay, yeah, good. Um, Amok, can you tell me what is mean by VLSI and what are the different domains will be there in VLSI?
Okay, I'm Amog and I'm from Mumbai, Maharashtra. The VLSI stands for Very Large Scale Integration. There are two main domains in VLSI. One is the front end and one is the back end. So the front end consists mainly of design verification, RTL design, which is a register transfer level, RTL logic, and the third is DFT, which is designed for test. And in backend is mostly physical design and timing analysis and other things.
Okay. Charan, can you explain what are the different steps involved in a design and verification?
Sorry, ma'am.
Okay, you don't know the answer?
No, ma'am.
Okay. Charan Kumar, can you explain now what are the different roles in front end domain and what are the steps involved in front end?
My name is V. Charan Kumar. I am from Bangalore. I am currently pursuing my Bachelor's of Technology. In front-end design, there are four steps involved. First step is specification. Second step is architectural design. Third step is RTL coding. Fourth step is functional verification. In backend domain, we will be having floor planning, placement, and clock tree synthesis. Next, routing, then static time analysis, physical verification and sign off. At last, tap off. These are the steps are involved in front end and back end design.
Okay, yeah, good. Next, Sai Manisai. I already asked, right? Question.
Yes, ma'am.
Sai Ishwar. Can you tell me what is the difference between RTL design and functional verification?
Good evening, ma'am. I'm Saishwar from Hyderabad. Hello.
Yeah, please continue.
RTL design and functional verification. Ma'am, RTL design is that
Yes.
designing a circuit, ma'am, just in a simulation form. And verification means verifying the circuit, like writing test benches.
Okay, what is mean by functional verification?
Functional verification means we are checking every wire, ma'am. Means if um, if we if a circuit is ready, just we are checking the inputs way at every stage, ma'am.
Every stage means?
Like it as it is entering the gate or not, at which level, and what are the changes comes after the gate, like that, ma'am, for the
No,
inputs.
no, it's wrong. What is mean by functional verification? Pavitra, can you explain?
Ma'am,
Yeah.
functional verification uh, using Verilog and the UVM method to find, verify the circuit, like
Mhm.
documentation, test cases,
Document. Okay.
test cases to verify the circuit.
Functional verification means we verify the functionality of a design by writing the test cases, by applying the input test vectors to the inputs and checking the output is nothing but functional verification. Okay, what it means, suppose there is a full adder. What is the functionality of full adder? There will be three inputs, two outputs, ABC inputs, sum and carry or outputs. Sum equal to AX or BX or C, carry equal to AB plus BC plus CA. Like that, multiplexer have its own functionality. Like there will be 2 power n number of inputs and selection lines and one output. So based on any selection line, the input must be sent to the output, right? So the functionality we are verifying. Okay, before who is him? Sai, na? Sai answered that we check the gate at a gate node, whatever we are observing the value at gate node, that is a testing. Okay, it's not a functional verification. Verification means suppose A is equal to 10, B is equal to 5. If you are let me write, I will show you. Is the screen visible?
Yes, ma'am.
Suppose there is a full adder A plus B plus C. Okay, A is equal to 5, B is equal to 6, C is equal to 10, or else it's a single bit also you can consider. Okay, suppose if there are three input variables, how many combinations we will get?
8 combination.
8
Eight
combination.
combinations. Functional verification engineer means we need to get the 100% verification is done or not. We need to check every corner case scenario. If input is a 3 bit, we need to verify 2 power 3 corner case scenarios. If input is 4 bit, 2 power 4 cases are important. If input is 5 bit, 2 power 5 number of cases we need to verify. If input is 32 bit, 2 power 32 number of cases we need to verify. But if you don't verify any case, there may be chances of getting the error for that case. Okay, if you don't verify all the cases at a front end domain, maybe that errors may escape to the back end process, physical design process. Even if you don't capture that bugs in the physical design verification at a physical verification, it will go to the post silicon. Post silicon means after dumping into the chip. So if you dump the design with more errors into the chip, then the chip doesn't do the functionality, right? Proper functionality. So entire chip cost is wasted. Till now, whatever the front end domain, back end domain we did the testing, everything will be wasted, right? So we should not escape any corner case scenario in the front end verification or in the back end verification, whether it is a formal verification or functional verification. Okay, 100% test cases should pass. At the same time, 100% coverage must hit. That's what the functional verification. Okay, suppose I am writing A is equal to 1, B is equal to 0, C is equal to 0. A plus B plus C. What is the value of A plus B plus C here?
1.
A plus B plus C is equal to 1 we should get. But we may got A plus B plus C equal to 0. Okay. That means that 0 is not a correct answer. Okay. So if output is not getting correct answer, the circuit is not working properly. Whatever the design we have written, that is not working properly. Maybe there may be any connection issues or any functionality issues may be there, or any delay issues will be there. Okay. So functional verification means verifying the design by applying the inputs to the, suppose this is a design, full adder design A, B, C, sum, carry. Functional verification means we apply the test inputs or test vectors or test stimulus. Okay, A equal to 0, B equal to 1, C equal to 0. Like that, 8 combinations we will apply. After applying, if you check the sum and carry, if the output is getting correct, then the functionality of the design is correct. If the output is wrong, that functionality of a design is wrong. That's what the functional verification. Okay. Before Sai, whatever you told, suppose here gates are there for full adder, there will be 3 AND gates, one XOR gate, and there will be 3 OR gates, one OR gate. So, as you told here, you are telling at gate node to node, we will check some values or like that you told. That is not verification, that is testing. So, whether node at every node the value is getting correctly or not, whether it is getting 0 or 1, any timing issues are there, any clock issues are there, any setup time analysis, hold time analysis, stuck at false are there. If we check all these things, that is a testing. A testing comes under DFT, design for testability. That role is different. Functional verification is different. Functional verification means suppose sum is equal to AX or BX or C. By applying the inputs ABC, whether you are getting sum is equal to AX or BX or value correct or not. That's what the functional verification. That functional verification we do using Verilog HDL and system Verilog UVM. Okay, compared to these three, which one is the best one means system Verilog and UVM are best. Why not Verilog HDL means in real time we work everything with a complex designs like IP level or SOC level. There will be very complex designs, right? So it is not very easy to verify using Verilog HDL because it have a very limited constraints. It doesn't have advanced verification concepts in Verilog. So Verilog is much suitable for RTL design. System Verilog and UVM are much suitable for verification, whether it's a functional verification or formal verification. Okay, did you got the point, everyone?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am. But I have a question related to that verification. Suppose I have 32-bit adder
Mm,
or num for 64-bit adder, then
mm.
my combination will be 2 to the power 64. In case of 3-bit adder, I can write 0 0 0 0 0 0 0 1. It is possible to write the code. But in case of that much number, huge number of combination, how can I
Hmm.
write the code or something like that? So it was manually write the check the all the combination. It was a tedious
That's what.
task.
See, that's what I told. If you write if you write the test cases using Verilog HDL, manually we need to write a 2 power 32 cases. Even we cannot write manually for 2 power 4, 2 power 5 also. It is very difficult to write manually 32 cases, 64 cases also we cannot write. How can we write 2 power 32 cases? That's never possible using Verilog HDL. But in system verilog and UVM we can use because we directly do the randomization concept will be there. We can randomly generate the scenarios, whatever the required scenarios are there to verify those particular scenarios we can verify. That's why specially we have a system verilog and UVM for verification. Okay.
Okay, ma'am.
Yeah. Next question, Stephen. Can you explain the physical design flow? Like what are the different steps and what we do in each step?
Yes, ma'am. In physical design, we used to do the simulation test, running the schematic capture, and then there will be layout designing for the same simulation or the schematic capture. And then once layout has been done, uh, we used to run over the DRC check and then the layout to the synthesis LVS check. And then once LVS is also done, then we used to go to place and route. So once place and route is done, so it'll be we run the timing characterization and after the timing characterization, it'll be ready for fab.
Okay. Yeah. Next question. Amog, can you explain what is the difference between pre-silicon verification and post-silicon verification?
I don't know the answer. I don't know the answer clearly.
Okay, you just tell me what is the difference between pre-silicon and post-silicon.
Pre-silicon is done before the fabrication process,
Okay.
and post-silicon is done after the fabrication process.
Okay, so in pre-silicon before fabrication process, we do the verification in our front-end domain, RTL design and verification, and also physical design. After physical design, also we do the verification. If we do in before fabrication, that's what a pre-silicon verification. If we do after fabrication, that means the layout will be dumped onto the silicon wafer. That time also we need to do the verification because in pre-silicon if any bugs escape to the post-silicon we need to capture there and we need to find out the error and we need to debug the issues. Okay, so that's what the post-silicon verification, that is also a major domain we have. Okay.
Okay.
um, on post-silicon verification, we are conducting a workshop in a ProV Logic in Hyderabad next month, mostly in February. If anyone interested, we are taking very limited people, just 2 or 3 members only per batch. If anyone interested, can come for low power verification techniques. From AMD, one of the person is going to come. He have nearly 15 years experience in AMD, working as a MTS, member of technical staff. So it's a 15 years experience role. So if anyone interested, can come.
Is it online or in person, ma'am?
Ma'am, it is
It's
1 day
offline.
workshop.
Okay.
It
Yeah.
is 1 day workshop.
Huh? Only
It is only 1 day workshop.
one day, not 1 day. It's 2 days. Saturday,
Okay.
Sunday.
So for that, is there any registration process? Is there?
I will let you know once we started announcement. I will let you know. I will post in your group. Okay.
Okay.
So that's what pre-silicon and post-silicon verification. Okay. Next, Gunit, can you explain what is mean by nanometer technology and how do we calculate the size of the transistor?
Yeah, nanometer technology refers to how recently transistors are becoming nanometer size. And when they say nanometer, they actually mean the length of the transistor. And you're asking how do we calculate the size of a transistor? Well, if I get to the physics of it, the width is determined by the width of the length is determined by the distance between the source and the gate. I mean, the source and the drain, and the width is determined by what's like the width or like width of this diffusion of charge in between source and gate. Is that what you're looking for, like the scientific reason, or?
Yes, yes, that's correct. Can you tell me what is the nanometer technology we are using in current mobile phones or any applications like in laptops or anywhere?
Like you're asking like how many nanometers we're using
Mm,
now?
mm, mm,
Um, well, we're in ultra deep submicron technology era right now. It's the 10 to 20 nanometers. Or no, it can be up to 60 nanometers.
mm-hmm. Not beyond that.
But it depends if you're using, I mean, yeah, it can be bigger, but it depends on like what like phones and like ICs, I think, or maybe 60 to 100.
Mm-hmm. Okay. Okay, but not 20. We are using very beyond that also in recent process. I will say. Sai Ishwar, can you explain what technology we are using currently? What nanometer size?
No, no, I don't have it.
Next, Ramu.
Madam, I think a 2 nanometer technology,
Mm-hmm. In which application?
and like phones or laptops.
Mm, yeah. In recent Samsung or Apple mobile phones, the recent versions like 17 Pro or 17 Pro Max, in that they already declared that they have used 3 nanometer and 2 nanometer technology. Okay, so it's nanometer technology is nothing but the size. How do we calculate? Means the distance between the source and the drain, because the CMOS have the three terminals. Source, drain, gate, and also one terminal body. So the current flow will be always the source to drain, right? As I explained already, the concepts and all. So the distance will be the distance between source and the drain is nothing but channel. That's what the nanometer size. Okay. Next, Manisai, can you explain what are the fabrication technologies we have used? Like, what is the type of transistors we have used in this nanometer technology?
No, ma'am, I have no idea.
Have you not joined for the previous sessions starting?
Ma'am, I have joined, but due to some, I was in like in my village, like there is some internet issue, so some on and off like kind of thing, ma'am.
Then you need to go through the recorded session. You got the LMS access, right? Recorded sessions,
Yes, uh,
assignments, materials.
yes,
Have
ma'am,
you,
yes, ma'am.
everyone? Did you completed the weekend test for digital?
Yes, ma'am,
Ma'am, I'm
completed.
facing one issue with the
Mm-hmm.
alarm portal. So I'm able
Yeah,
to
you
log into the
said.
main dashboard, but I cannot.
Mm-hmm.
Once I log into my test, I
Mm-hmm.
mean the weekend test portal, it
Mm-hmm.
it just stays on verifying, but it never goes beyond that. I even
Mm-hmm.
sent the screenshot to the HR team.
Okay,
They
they
still
will
haven't
respond
responded.
tomorrow.
Yeah, yeah,
Today's
they still
Sunday,
haven't
right?
responded. So I'm just
Ma'am,
waiting
I'm
for that.
also not getting logged in into it now. Just I
What?
conveyed message on Friday, but they are not
Mm-hmm.
responding.
On
Yesterday also I
what
messaged.
issue you are getting?
It is like just a minute. Uh, just a minute.
Not authorized like that you
Yeah,
are
ma'am.
getting,
Not
huh?
authorized. Not authorized. Yes.
Okay, okay, okay.
Actually, I have
There.
opened one previously, ma'am.
Mm-hmm.
But yesterday, Friday on Friday, access was like that.
Yeah, yeah. Some students are getting like that. We already cleared that issue for all.
Mm.
Tomorrow morning we'll see. Okay.
Okay, ma'am.
Yeah. Okay. Next question for Pavitra. Pavitra, can you explain what are the fabrication technologies? Like what type of transistor we are using from last micrometer, nanometer technologies?
I don't know, ma'am.
What type of
The
transistors I am
fabrication.
asking? What type of transistors? Tell me whatever you know, the transistors, the names.
Okay, ma'am. Like CMOS transistors, அது மாதிரி, right? CMOS,
Okay.
NMOS transistors.
CMOS.
The
Okay.
combination of PMOS and NMOS transistor is the CMOS transistor.
Mm-hmm. Next up, CMOS transistors. We have discussed others also. Raumik, can you explain?
Uh,
Yes, ma'am. First of all, MOSFET, uh, FinFET, GAFET, and if I goes beyond 2 nanometer or something, then quantum technology, qubits, uh, has been used. For 16 nanometer, below 16 nanometer, we use GAFET, FinFET.
Okay. So why are we moving to these many technologies? What are the limitations we are facing in every technology, and why do we move to these?
In case of MOSFET, when we are reducing the gate length, means suppose 100 nanometer to 50 nanometer, then there is a problem is that the leakage current. Okay, uh, and uh, there is when the distance between source and drain becomes smaller. Uh, another thing happens that the minority carriers leakage happens from gate end. So to reduce that problem, we need to uh, choose another architecture that is FinFET. And if I goes make the length between source and drain more smaller, then we need to change the architecture that is gate all around FET. Okay, to stop that leakage. That's all.
Yeah, good, correct. Yeah. Next, Stephen, can you explain what is mean by Moore's law?
So Moore's law states that as years pass, the size of the transistor gets decreased twice every year.
Okay.
And right now we are in 2 nanometer technology.
Okay. Can you tell me what are the classification of integrated circuit?
Um, Classification of AC. Um, like for example, I cannot understand the question clearly.
What are the classification of IC in IC from last 100 years? What are the different technologies we are using? in integrated
Uh,
circuit like SSI, MSI, LSI, ULSI?
no, ma'am, that part still haven't gone through.
Charan
If it's
Kumar,
like
can you
different,
explain? Okay, just wait. We'll see from others. Charan Kumar, can you
Eh,
explain IC technologies?
Yes, ma'am. First of all, what is mean by IC means IC is an IC stands for integrated circuit. IC is a small electronic chip in which many electronic components like diode, transistors, resistors, capacitors, inductors are fabricated together on a single silicon chip to perform a specific operation or task. Coming to classifications of ICs, there are five classifications of IC: SSI, MSI, LSI, VLSI, ULSI. SSI stands for small scale integration. It uses very few logic gates, range from 0 to 10. The application for SSI are logic gates are NAND, NOR, and R logic gates. Whereas MSI stands for medium scale integration. It uses medium number of logic gates, range from 10 to 100. The application for MSI are marks, demarks, encoders, and decoders, whereas LSI stands for large scale integration. It uses a large number of gates, range from 100 to 10,000 logic gates. The application for LSI are counters, registers, and flip-flops. Whereas VLSI stands for very large scale integration. It uses a very large number of gates, range from 10,000 to 1 million. Uh, the applications for VLSI are microprocessor and microcontroller, as present technology is going on this VLSI. The upcoming technology is ultra large scale integration. It uses extremely large number of transistors, range from 1 million to 10 million logic gates. Uh, the application for ULSI are CPUs or GPUs. Yes, ma'am.
Yeah, good. Yeah, that is also correct answer. And also, I have told right a simple example how you can remember. Like I told you example like a 2G, 3G, 4G, and 5G mobile phones. Like 2G mobile phone is a keypad mobile phone where it have the minimal hardware, right? Just it have a simple processor and just a small battery like that, where we do very simple. Even telephone is one of the example for small scale integration. Telephone also having a simple chip, even it doesn't have any battery like a 2G mobile phone. It's very simple chip like that. From olden days mobile phones to now, the chip size is reducing and the size of the transistors are increasing rapidly. Why? Because at 2G mobile phone we just use one simple processor, normal general purpose processor. But 3G, 4G, 5G, if you observe, we are using lot of architecture, right? Like a graphic processor, video processor, audio processor, image processor, multi-signal processor, digital signal processor, even number of cores are increasing into the processors, right? So because of these advancements, nowadays we are able to run the AI applications also. Okay, if we want to run a high level applications or high level software applications on top level, we must have a proper hardware at a low level. If we don't have the supportable hardware for the software, we cannot run that softwares, right? So even nowadays we are using chat gpt, AI, a lot of clarity pictures we are generating within a seconds, means because of internal hardware only. You can even simply observe by taking the difference between iPhone and a normal phone, like a normal 10,000 mobile phone. You just play a game and you can observe easily like which one is giving the better performance in terms of speed, in terms of softness in the screen, in terms of power. Okay, you can even iPhone works. It doesn't have any hanging issues or slowdown issues. But if you play same game in a normal mobile phone, you will be getting a lot of slowdown issues. Sometimes the mobile will stuck or hang. Okay, so these are the advancements coming into the reality. So based on that, the architecture is also increasing, right? Whenever the complexity of the design components are increasing, obviously the architecture increases. So here the Moore's law is satisfying. That means the number of transistors will be double for every 2 years. At the same time, the size of the transistor will be reduced to half. So here the rule is satisfying. So that's what different classification of integrated circuits. Okay, everyone clear?
Yes, ma'am.
Yes, madam.
Okay. Next, Amog, can you tell me what is mean by a motherboard, which is nothing but the VLSI chip, and what are the major components you have observed on the motherboard, and what is the importance of every component?
A motherboard is actually a printed circuit board. It is a PCB which consists different which consists of different elements like the CPU, the RAM, the US, the SD card, the SD card, and other the GPU and all other elements which are embedded inside the motherboard. Like they are attached on top of the motherboard.
Okay, okay. Next, Gunit, can you explain what is mean by a processor and what are the internal blocks available in a processor?
Uh, Processor is like it's kind of like the brain behind any system. It executes instructions essentially. And the different components I can think of in a processor include you have caches, you have instruction registers, you have memories, you have what's it called, adders, and like different ALU components. You have interconnect buses. You have um let me think of like other components. Uh maybe like you have like application IPs can have communication
I am
subsystems.
asking not in entire SOC. I'm just asking what will be there in a processor, just in a processor.
Oh, processor is just uh arithmetic unit like ALU instruction register and memories.
Mm-hmm. Okay. Still, anything?
Uh Communication subsystems.
Mm-hmm.
Uh Trying to think of a couple more. Am I missing a lot right now or
Okay. Sai Ishwar, can you explain what are the different IPs available in a processor? Sai
It's
Ishwar.
like uh, I think permanent board man. Mm, once the code is inserted, cannot be replaced type of things and can be replaced type of things.
I'm asking what is mean by a processor? What are the different IPs available in a processor?
IP. Oh, okay.
What are the different blocks available in a processor?
It consists of core man. Means
Yes.
IPs, memory. I, mem-
Okay. Can you tell me what is mean by a core?
Sub-processors in the main processor, like core.
Okay. How many cores will be there in a processor?
Unable to
Okay.
get it.
Okay. Ramu, can you explain what is mean by a processor?
Madam, okay, in processor is a central processing unit which performs the calculations and the instructions and managing the data flow, madam.
Okay. Still, Manisai, can you explain what is mean by a processor?
Processor is a device which performs tasks on the basis of the instructions, and we
First
can.
of all, processor is not a device. It's just a
Okay,
component.
yes, ma'am.
Do
It's
you
a
know what
compound.
is the do you know what is the difference between device and a component?
No, ma'am.
Okay. Device means your laptop is a device, your mobile phone is a device, computer is a device. Okay. Printer is a device, a scanner is a device, a micro oven is a electronic device. These are devices. Okay. It's a products. These are products, nothing but devices. Component in the sense internal design, internal hardware. If there is a simple one just a component, like there is a motherboard, I already shown you. In motherboard there will be lot of components, like processor is a component, graphic processor is a component, um, memory slot, the ram slot is a chip, it's a component. There are side ports will be there. These also different types of ports or components we call. Okay, device is different, component is different.
Ma'am, what you're saying is like a combination of components form a device.
uh yeah, of course. Form combination of components form a chip. Suppose
Okay.
motherboard is there. Do you know motherboard? Have you seen
Ma'am, I
motherboard?
Yes, ma'am. We have seen in the video, like you have shared
Ah,
one video in the group, like.
yeah. So in that motherboard, there are combination of components. If we put that motherboard in somewhere, some in particular computer or in a laptop, in laptop there will be lot of, like, motherboard will be there, keyboard will be there, mouse will be there, touch screen will be there. This entire product we call as a device.
Okay, okay, ma'am. Ma'am, I have a doubt. Like, we can call a processor like a component, but
Hmm.
uh, like a combination of components, we can form a chip,
Yes.
and with chip with external all the peripherals, we
Yes.
form a device. Is that right, ma'am?
Yes. Yes.
Okay, ma'am. Okay, ma'am. Coming to the
ma'am,
question you asked.
I have a question related to this.
What?
Is that the transistor, it is a component or device. When we read the semiconductor device physics, then it is mentioned that it is a device.
Okay. Okay. Maybe at a
Okay, the
transistor level, they may talk as a device, but device means it's a product. Product we call as a device. These all are transistors are simple components, right? Components we insert on a simple IC, on a single IC. Did you got my point?
yes,
Yes, ma'am. Yes, ma'am.
Okay. Just check once again, uh, and send me screenshot in the group. Okay. Next, yeah, Sai, you are answering something.
Ma'am, the question you asked is like, what is a processor?
Hmm.
Processor is a component. we can program it to perform some particular or specific tasks. Like it contains registers, arithmetic and logical units, program counter, data bus, all that, which this the combination of all this forms a processor, ma'am.
Okay. Pavitra, can you explain me what is mean by a processor and what it do?
Okay, ma'am. The processor that is small chip that executes instructions and perform calculations and manage the data flow to operate the system called processor. It's a brain of the computer. And to process, ma'am, next question, ma'am. First, what is in the processor? Next,
Um, what is the use of a processor?
okay, process. It interconnects the control unit ALU registers.
Okay.
Is correct, ma'am, or not?
Okay, I will explain. Raumik, can you explain? Did you answer for this question?
Me, not
Okay, explain now.
what is processor or
Yes, what is mean by a processor? What are the different blocks available in a processor, and what is the use of a processor in a any system?
processor is have code plus cache memory. Okay, code is basically architecture. Uh, in a processor, inside a processor, there are different kind of register, arithmetic logic units, uh, bus, address bus, data bus, and yes, and for executing programs and storing the value, there is a processing units, and the function is of the processor is to take instructions and execute the instruction and read and write the instruction.
Okay, yeah, good. That's it.
Yes.
Okay. Next, Stephen. Can you tell me the same question?
Ma'am, sorry, ma'am. What's the question?
What is mean by a processor? What are the different blocks available in a processor, and what is the importance of a processor?
So a processor is again a component that will perform the logical operations. Um, Whatever the logical operations we give the instructions to, and then the different types of processor is like ARM processor or RISC-V processor. Is that what you mean exactly, or?
Okay.
And then the importance of processor is like it's the main component of a computer system, uh, which performs the instructions what we give, and then process the data, and then transfers the output as well.
Okay. Mm. Charan Kumar, can you explain what is mean by a processor? What are the different blocks available in a processor?
Yes, ma'am. Ma'am, a processor is a brain of the system. It takes input, process it, and produce output. For an example, uh, processor is an automatic logic unit. Uh, it performs all automatic operation. It process all automatic operation, right? If we take addition, at the input we will do 2 plus 3. If then it goes to the processor, it runs the algorithm and it produces the output. that is called processor. Yes, ma'am.
Yeah, okay. Almost okay, correct. Okay, first of all, what is meant by a processor means you are telling processor having ALU, processor having some control bus, not like that. Okay, first of all, processor is a subsystem. Okay, in subsystem, it have number of IPs. Okay, core is a IP. Suppose here I'm. Is the screen visible?
Yes, ma'am.
Yes, ma'am.
Suppose it's a SOC. In SOC, there will be processor subsystem, memory subsystem, some IO peripheral subsystem, and some other subsystem. Okay, when it comes to processor subsystem, inside it have a number of cores. It's a 2 core or quad core or octa core or 16 cores based on i3, i5, i7, i9 generations. You see, right? So it have number of cores. And it have number of cache memories. I already told you what is mean by cache memory, primary memory, secondary memory, ram, rom, fifo, lifo. Okay, so it is having cache memory in a processor. Okay, can you tell me anyone what is the importance of cache memory in a processor?
Hello, madam.
Yeah.
Madam, cache memory is a temporary and small memory which sits between the processor and RAM. It stores
Mm,
the recent data, madam. And the
mm,
processor will access the data from cache memory and will do the performance very fast.
mm. Yes. So cache memory having the number processor having the number of cores, right? Processor is first of all, it's a brain of a computer. Like however the human brain is working, the processor work in the same way. It runs a millions of instructions per second. That means the entire SoC, the entire hardware, the entire software, everything is controlled on a processor. Processor is controlling entire system. Okay, it generates a millions of instructions per second. That instructions storing some data, right? Instructions means it have registers R1, R2, R3. You have written assembly language programming, add R1, R2, sub R1, R2, like a multiplication, jump, branch type. There will be lot of instruction set. Okay, uh, so that instructions will be running by the processor. So whatever the data is there here, instruction data or the register data, that will be stored in the cache memory, because that millions of instructions should be accessed faster, right? Cache memory means even if you go to the Google, if you are searching something, if you search for again second time, you don't need to search entire name. If you just probilogic.com is there, if you search first time, you need to type entire probilogic.com. If you search for second time, if you just put p, you will get entire probilogic.com. Just you are using only p. So that's what the cache memory, even for processor. Okay, outside the processor there will be a memory which is called RAM. Okay, so every time if it want to come outside and fetch the data from the RAM, it's a long process, it's a time taken process. Okay, that's why we have a cache memory, internal subsystem of a processor, so that all the instructions can access the cache memory, it access the fast. Okay, so that's what the cache memory. Coming to the core is nothing but I already told you, it do the multiple task, like whatever the system speed is there, the system speed will be dependent on the core, because core will do the number of tasks, it run multiple tasks. Suppose one core will run two tasks, two cores will run four tasks, four cores will run eight tasks, eight cores will run 16 tasks. Okay, so whenever your core is not sufficient according to your application, automatically your system will slow down, or you will get the hanging issues, the software doesn't work properly. So core is a major thing to run entire software at a high level speed. Okay, so that's what the core. In the core, what will be there, in the sense there will be a core architecture like a RISC-V architecture or CISC-V architecture, MIPS processor architecture or x86 architecture. In that architecture there will be different types of architecture blocks. That's what arithmetic and logic unit, general purpose register, special purpose registers, control bus, data bus, accumulator, program counter. All this architecture combinedly we can call it as a core. Okay, I already explained all these things for you in the first session, sir. Have you not remembered?
Yes, ma'am.
Okay. Next question. Just need to revise again.
Remember,
What? Hello. Hello.
Yes,
Yes, ma'am.
yes,
Okay.
ma'am.
Screen is not visible. Okay, let me reconnect again. Hello. Yeah, am I audible now?
yes,
Yes,
ma'am.
Yes,
You're
madam.
ma'am.
audible.
Okay. Next
Yes, ma'am.
question. Next question is for Amol. Can you explain what are the different types of memories are there in SOC level? What are the different types of memories are there in SOC level?
It is RAM cache memory. Then you have the SSD memory.
Okay.
Then you have ROM, which is the random ROM also is there present.
Okay. What is the use of each memory?
So the cache memory is present inside the processor. The RAM memory is the one which is uh, in which in which the in which is connected to the processor, and the cache memory gets all the data from the RAM, and the SSD memory is the memory where all the data of the device is stored, like the data, like all the data is stored in the SSD memory, or in the SSD memory.
Okay. Gunit, can you explain what is the difference between sequential access memories and random access memories, and what are the classification?
Wait, sorry, you said difference between sequential access memory and random access, like and RAM?
Yes.
And then what did you say after that? Like
What?
wait, what did you say after that?
I'm asking what are the sequential access memory and random access memory. Yesterday I have discussed in digital
Oh yeah,
electronics.
yeah. What sequential access memories means like when you store the data, you store it in like a order, like sequential order, fixed order. Uh, and then random access memory means that like like, so wait, sorry, but the fixed order thing, that means if you want to like go to location 7, you have to go through 1 through 6 first, and then you get to 7. So you gotta read like the earlier data first before you read the later data. And random access memory means you can access any like location directly, or and like it's much faster. I mean, you have DDR, SRAM, and RAM, and what's it called? What was the question after that?
What is the use of each application?
Um, I mean, I know RAM you kind of like RAM is like used like close for like quicker actions. Um, like you use cache, a cache will use like SRAM, a CPU like needs RAM to like access data quickly. Uh, what's it called for sequential? Um, I would say uh like something like a log file, maybe you need like sequential memory, like, or when I'm copying like large amounts of data, I would say like I need sequential access, like sequential memory.
Okay.
Or for example, like I like when you work with like media, like I want to say like Netflix or something, like Spotify, like they use buffers, right? So buffers like store all the like the data sequentially, and then they transfer it. Is that correct? Or
Okay, fine. So yeah, mostly we use to connect. RAM is like it's a temporary storage purpose, like whatever the drivers or the softwares we are running, right? Those will run on RAM only. ROM will run like a boot process, like boot flow for operating system, which is a permanent storage. All these we run on ROM. Coming to the FIFO and LIFO memory, these are the sequential access memory which we use inside the memory design, like any access, like there are a lot of concepts we use between device to device, or between component to component, or inside the verification purpose also. We use FIFO sometimes. There are a lot of applications. Okay. Next question, Sai Ishwar. Can you explain what is the difference between ASIC, FPGA, and SOC?
Mm. Yes, ma'am. ASIC, um, these are the boards, ma'am. ASIC board means it's a permanent board. If we insert a code, it cannot be changed, ma'am. And
Okay.
FPGA can process multiple times, ma'am. Like if
Mm.
ASIC board means it's a motherboard, ma'am. We cannot once the motherboard is trashed, we cannot replace the components in it, ma'am. Just we have to change the motherboard.
Mm-hmm.
FPGA is not like that, ma'am. We can process multiple times.
Okay.
And SoC is system on chip, ma'am. It consists of processor like GPU processor, AI accelerator, memory, IO peripherals, and computations, ma'am. It is it is connected internally with bus, ma'am. SoC.
Okay. Yeah. Good. Um, Ramu, can you explain what is the difference between ASIC, FPGA, and SOC?
Uh, Hello, madam. Can you hear my voice?
Actually, Ishwar told that ASIC chips we cannot replace, like motherboard components we cannot replace. Somewhat you said that is not correct. Actually, I will give the clarity.
Okay.
Madam, on FPGA, we can reprogram so many times, madam. We can
Okay.
reprogram as many times as we can. And whereas in the ASIC it is a permanent, we cannot change its program code, madam. Once it's after fabrication, it will be there. Only if it is damaged, we have to change entire chip, madam. ASIC chip. We have to change the entire ASIC chip.
Okay.
Whereas in
Mhm.
SOC, we have clusters of subsystems. In the clusters of subsystems, we have IPs, madam. And the clusters of subsystems like CPU, GPU, RAM, peripherals, accelerators, madam.
Okay.
And these are all onto a single chip, madam. Onto a single chip. In the SOC,
Okay.
we use a single chip, and all these are subsystems are integrated on this chip, madam.
Okay. 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 Anyone want to explain more clearly?
Ma'am, ASIC is an application specific. So once we design the chip, we can run the chip only for one specific application, what it is designed for. Whereas in FPGA, we can run it for multiple applications. Like whatever the instructions we want to provide, we can provide it for different applications and we can program it and run it.
Okay. SOC.
SOC is a general part, like as you said, it's a brain of computer where it'll have we can run any number of instructions on it. So as it is present in like laptops or mobile phones, so whatever the instructions we fed into, based on what instruction data we give, so it can run anything. So it's like contains all the subcomponents inside it.
Okay. See, ASIC, no one said proper answer. There are few changes. Actually, ASIC is a application specific integrated circuit. It's a permanent. Like once we dump the code into the integrated circuit, we cannot rechange the code. That's what ASIC chip. Like a motherboard. Motherboard is a PCB board. It's not like a chip. Okay, it's not a SoC. It's not a system on chip design. Okay, it's a PCB board. On PCB board, we are connecting lot of components like processor, graphic processor, RAM. There are a lot of peripherals, South Bridge IO, North Bridge IO, PCIe. There are a lot of, okay. All these chips comes under ASIC chips, which can be replaced. You are telling you cannot replace once it is damaged. We need to. I'm telling component can be replaced, like a component we can, suppose processor is damaged on your motherboard, okay, I can remove that processor and can put new processor. Okay, last time I have shown you videos, right? I have sent videos to your WhatsApp. Okay, so that is a motherboard. If any processor is damaged, we can remove that processor and we can put another new processor. But internal processor, like internal, whatever the coding part is there, whatever the hardware architecture is there, internal processor, that's what we cannot change. That's what the ASIC chip, once the program is dumped into the chip, we cannot rechange that program. We cannot reprogram it again and again. Okay, that's what a ASIC chip. A motherboard is a ASIC chip, but the components we can plug and play manner. If you want to put more another component, you can put and you can remove. We can. That's what motherboard. Coming to the SoC itself is a chip. It's a single chip. Like in motherboard, however, a component is there, a processor. Like that, SoC is a processor type chip. If I want to tell simply, it's a chip. On the chip, we are putting multiple blocks, multiple processor, memory, subsystems, everything we are putting onto the SoC. Okay, that SoC, if anything is damaged, you cannot replace or you cannot put plug and play manner. You cannot put any component which is not plug and play manner. Did you got my point, everyone?
Yes, ma'am.
Like a
Yes,
simple
ma'am.
example, TV. Olden days TV, if you see, there will be big box size TVs. On in TVs, what will be there? There will be a PCB board. In PCB board, there will be multiple components like capacitors, processors. There will be lot of TV related image processors will be there, video processor for more clarity, graphic processors will be there. That that can be, you can put on to the PCB board. If anything is damaged, they will, if you go to the TV repair shop, they will remove that component which is damaged, they will put with a new component. Even if any capacitor is damaged, they will put a new capacitor to the motherboard. Okay, but chips, system on chip designs are not like that. If you go, nowadays TV, if you take nowadays TV, very slant TVs, not like a big box TVs, right? If you take the TV to any shop, if anything is damaged inside a hardware, they cannot replace that component. They will tell you simply the chipset is damaged, you need to replace entire chipset with a new chipset, chip board, entire board you need to replace. That's what a system on chip design. Okay, everyone got the point?
Yes, ma'am.
Yes, ma'am.
Yeah. Coming to the
Ma'am,
FPGA,
the
tell.
an ASIC chip that is replace a component.
ASIC chips means,
Especially not
mm, mm,
chip
ASIC
means
chips,
replace
see, ASIC
replace
chip
component.
means, yeah, wait, I am telling.
Okay.
ASIC చిప్ అంటే ఇప్పుడు మదర్ బోర్డు ఉందా, మదర్ బోర్డు మీద ప్రాసెసర్ ఉందా, ఆ ప్రాసెసర్ ఏసిక్ అంటే ప్రాసెసర్ లో మీరు ఒక నెట్ లిస్ట్ ని డంప్ చేశారా,
Ma'am,
నేను ఆ వీడియో కూడా
I
చూపించా
don't know
మీకు.
Telugu.
యు డోంట్ నో తెలుగు? ఓకే.
Yeah.
In motherboard, on top of motherboard there are multiple components. That's all ASIC chip only, because inside the component, inside the processor, you cannot replace the programming. That's what I'm telling, the programming you cannot replace, it's a permanent chip. To manufacture that permanent chip, what are the steps we need to follow? We need to follow entire VLSI design flow, right? Specification, architecture, RTL design, verification, physical design, entire physical design process we need to know. But coming to the FPGA, we don't need all that process, we just need to dump the program onto the board. You can use for application, again you can replace the program with another, you can use for multiple applications. Okay, ASIC chips are different, FPGA different, SoCs are different. SoCs are nothing but, by replacing with a PCB board, we just have some simple chip on chip. We just putting the multiple blocks, which is nothing but processor subsystem, memory subsystem, FPGA, AI accelerator subsystem, image processor subsystem, video processor subsystem, graphic processor subsystems. A lot of we just putting on a simple chip, not on PCB board. Did you got the clarity?
Yes, ma'am.
I will send pictures to your WhatsApp. Just see that you will get clarity, or else. Okay.
Okay. Okay.
Next question. Okay. Next, whose question? Raumik. Ramu, can you explain what are the different subsystems are there, and what are the different types of IPs?
Madam, in COC.
SOC, not COC.
Okay. So system on chip. We have subsystems like CPU, GPU, RAM, memory, uh, peripherals, and AI accelerators, madam. And also, we can connect for wireless communication.
Okay. Okay, next, Sai, Mani Sai, can you explain what are the different types of protocols out there at SOC level, and what are the different classification of protocols?
Protocols, ma'am.
Yes, protocol. What is mean by protocol?
Ma'am, firstly, protocol is a set of rules and regulations that a system should follow in order to like process the data.
Okay.
Ma'am, in SOC level, we have like AHB, AMBA bus protocol, ma'am. Ma'am, correct me if I'm wrong, but I
Mm.
remember like AMBA bus protocols,
Mm.
APB, AHB, AXI.
Mm.
Is it right, ma'am?
Okay. Yes.
Yes, ma'am. And like we also have protocols like UART and I2C.
Yes.
Uh,
Where do we use UART I2C and where do we use ABB, HB, AXI, PCIe, Ethernet, USB?
Madam, APB, AMBA protocols like APB, HB, AXI, we use them in like intra chip, ma'am, within the chip. Like UART and I2C
Okay.
are for internal, like chip to chip connection. For the chip to chip connection, we use UART and I2C protocols, ma'am.
Okay. Not chip to chip, device to device.
Device to device, sorry, ma'am. Device to device.
Hmm. Okay. Okay. Yeah. Good. Next, Pavitra, can you explain what is the difference between combinational and sequential logic circuit?
The combination circuits are the output is depends only on the present inputs, and the sequential circuits are the output is depends on the input, present input and the previous output. The combination logic circuits, the examples are adders, subtractors, multiplexer, decoders, and sequential logic circuits are registers, flip-flops. These are.
Okay. Next, Raumik, can you explain what is the difference between flip-flop and a latch?
Latch and flip-flop latch doesn't have a clock pulse, and flip-flop has a clock pulse. Latch have a issue of race around conditions, but in flip-flop there is no such kind of problems of race around. Latch is level triggered, whereas flip-flop is edge triggered.
Okay. What is mean by race around condition and what are the different ways of avoiding the race around condition?
Race around conditions mainly happens in JK latch, when JK latch with level triggered. And when the J and K both inputs are 1, means in toggle conditions, and when the clock width is much greater than the propagation delay of the flip-flop, then race around condition happens, where within a single level the input, there is a loop lies between 0 and 1, 0 and 1, 0 and 1 within a small period of time in a single level. So this is the race around. To avoid the race around, we need to use the H triggered clock pulse. Another thing is that we need to use master slave flip flop, and we need to increase the propagation delay of the flip flop. But among these three, the master slave flip flop is the most important solution, because it is very difficult to maintain the propagation delay of the flip flop and the ease triggering. That's all.
Okay. Yeah. Okay. Correct. Yeah. Okay. So, remaining concepts we'll discuss in the next week. So, from tomorrow onwards, we are going to start with a basic digital logic design. So, within 3 weeks, we need to complete the digital electronics. So, don't take much time and try to learn faster. Okay, don't spend too much time for the digital electronics. Okay, you need to learn in depth and also learn fastly. Okay, don't take 4 weeks, 5 weeks like that. The maximum 3 to 4 weeks we need to complete digital electronics, because in front there are a lot of things you need to learn like Verilog system, Verilog, UVM. Okay, so it's not a correct way to spend months of time for digital electronics. Okay, so my suggestion is to complete within 3 weeks, or else you can take 4 weeks. That's it. Okay, is it
Okay.
clear?
Yeah,
Okay.
Okay,
I
ma'am.
have a
It's clear.
Yes,
question.
ma'am.
Okay.
Uh,
Yeah,
I
tell.
have a question. Is the digital logic just the one big PowerPoint that's attached in our material section, like the 260 slide PowerPoint or
Yes.
PDF? Sorry, yeah. That's
Yes,
that's the
yes.
entirety of the curriculum covered for digital electronics, or is there more?
That is whole concepts I have shared. If you want the books, I will upload the books also. There are books nearly 700, 800 pages books also there. If you want to refer, I can upload. But PPT is the best option because you can learn in a simple and crisp.
Yeah.
Anyway, you will search everything from Google, ChatGPT, right? So that's why.
Okay. Yeah, I
and
thought the
also and also everyone start doing the assignments, assignment 1, assignment 2, 3, 4, like that, parallelly assignment. And with the digital PPT I have uploaded interview questions, PDF also. Start doing that also parallelly. Daily 1 hour, spend that interview questions PDF. If you have any doubts, you can ask. Okay.
okay. Like asked during
Mm.
class
Ma'am, I
or
have
Yes, yes. Yeah, tell.
ma'am, the last class was using and get to get a multiplexer. The concept I could not understand, ma'am. Once repeat, ma'am.
And get using a multiplexer, huh?
Yes, ma'am.
Okay, I will explain.
Thank you.
Is the screen visible?
Yes, ma'am.
Okay, any gate is the same processor. Okay, first of all, whatever you are drawing some gate, take the truth table of the gate. A, B, 0, 0, 0, 1, 1, 0, 1, 1. So what are the outputs? All zeros, 1. Now I want to draw this using a multiplexer. 2 by 1 multiplexer. 2 by 1 multiplexer means 2 inputs, 1 selection line, 1 output. Okay. This selection line we can consider either A or B. You can consider any one. Okay. Suppose I am considering, because this AND gate we are implementing with the multiplexer means you should not have any extra variables. Whatever the AND gate variables are there, with that variables only you need to build a multiplexer. Okay. Suppose you are building a demultiplexer for a decoder means whatever the input variables are there for demultiplexer, that variables only must apply to the decoder. You should not use any extra variables. Okay, you are implementing AND gate logic to the multiplexer means AND gate variables only you need to put for multiplexer. XOR gate with the multiplexer means XOR gate variables only you need to put for a multiplexer, not other than more signals. Okay, suppose now I am considering A as a selection line. So if selection line is a 0, what is the output? Multiplexer means what? Based on the selection line, any one of the inputs. Suppose 0 means this is a zeroth line. Whatever the data is there in zeroth line, that data will be assigned to the Y. That's what multiplexer. If selection line is 1, whatever the data is there in first line, that data will be assigned to the Y. That's what the multiplexer, right? Now I am taking selection line as a 0. So there are two cases. If I take selection line A as a 0, even you take B, there are two cases for B. Okay. So if selection line is a 0 for A, what is the output we are getting? Compare with the B. Okay. Whatever the B value is there, if a B is a 0, output is 0. If B is 1, output is there. Output is 0. Whatever the B value is there, Y is getting 0 only. That means this totally permanently assigned to the ground. If a selection line is 0, output is 0. That's what the uh, functionality here. Okay. Suppose if I consider selection line as a 1 here. Selection line as a 1. What is the output here compared to B? If B having 0, output is getting 0. If B having 1, output is getting 1. That means this particular line will be completely connected with the B. Okay. So that's what 2 by 1 multiplexer. Like the 4 by 1 multiplexer. If you draw 4 by 1 multiplexer, how you will draw? Here, two selection lines. So 1, 2, 3, 4 inputs. So 1 now. Now selection line consider as a B directly. If AB is 0, 0, output is 0. If AB is 0 1, output is 0. If AB is 1 0, output is 0. That means these three, whatever 1 2 3, these three should be connected to ground. If AB is 1 1, this only one is should be connected with 5 volts logic. So if AB is 1 1, the output will get as a logic 1. Okay, clear?
Yes, ma'am.
Okay. Any other doubts remaining?
Yeah, can you go over
Ma'am,
the JK latch? I don't like especially when J and K are both one.
Mm-hmm.
I'm trying to see what like the how it works.
When j equal to 1, k equal to 1, it go to the toggle state. Toggle state means if previous output is 0, next state will be 1. If previous input is output is 1, no, next state will be 0. That's what it do toggle. Like I already written here. Let me show. Here, toggle. Initially 0, next state went to 1, again 0, 1, 0, 1, 0, 1, 0, 1. T for toggle. Even
Yeah,
j is
okay.
equal to 1, k equal to 1 also toggle condition only.
Why
Both
does
are
it
same.
toggle? Can you trace the circuit?
Toggle means that's what I'm
No, no,
telling.
I know what toggle
Hmm.
means. I'm saying
Hmm.
why does it toggle? Like uh, based on the circuit? Like 'cause I don't know if I was
Mm,
doing it wrong,
yes,
but I
yes,
was
based
tracing
on
it.
circuit. Yeah. Yes, yes, yes.
Yeah, like
Whenever we discuss flip-flops, we will design the circuits in gate level. Then you will understand why we are getting the toggle. Because we need to observe by applying 0 0 input, we need to check output 0 1 1 0 1 1. That time you will understand. Okay, I
yeah,
got your
because
point.
I was tracing the circuit last night
Mm,
and
mm,
like when you apply 0 to J and or 1
mm,
1 to like J, K
mm,
and clock, after the
mm,
first NAND, the top J like after the first NAND, like the one on the top, the
mm,
input into the SR latch is Q, and the input
mm,
into the SR latch at the K side on the bottom is Q prime or Q naught. So I don't understand how if you take the NAND of Q and Q prime, it should be one, right? Like I was tracing the circuit and I thought that like when I was 1 1, like I felt like I was getting the same situation as a SR latch where it's 1 1 as well on like if you
mm.
apply 1 1 then Q and Q prime.
Latch and flip flop outputs are almost the same. Latch and flip flop is almost the same,
No, no,
but
I know that. I
the
meant like just the
mm,
SR latch by itself and the JK latch
mm,
or flip
okay.
flop, either one. Um,
Yeah, whenever we move to every concept, individual concept, you will get to understand. Okay.
oh, okay, okay. So that's this week. I honestly
Mm,
thought that we already covered all the concepts. I started reviewing all of them again. Okay, okay.
yes.
Yeah. Okay.
From tomorrow onwards, we are going to discuss everything more detailedly. Just last week, I have given a application oriented, like a overview of digital electronics. Okay.
Okay.
Yeah. Okay then, everyone.
Ma'am,
Thank you all. Yeah.
ma'am, you
Hello,
have
ma'am.
told.
I have a question.
Mm.
Hello.
Check.
Yes, ma'am. How can I submit the assignment? Because I
Uh,
was watching that
Assignment.
in.
Yes, yes. For assignment, we will provide you a mail ID. You need to submit there. Actually, we need to add the submission option there itself. We will add that soon. Meanwhile, you can share to the mail. I'll share you the mail in WhatsApp. Okay.
ma'am, when my issue
Mm.
will be resolved? That is
Tomorrow
access denied.
morning. Tomorrow morning.
Okay.
Yeah. Okay. Okay
Ma'am,
then,
I
Wait, for the
gave
everyone.
an
homework PDF. Oh, sorry, go ahead.
What?
For the homework PDFs, like we have to email them by what day? Like when is the due date?
You
Like
can
the assignment.
don't email everything. You just create a drive link for you. Drive link.
Mhm.
You just
Okay.
put the drive link. We will save the drive link at our side, and we will review every time that one. Okay, you can upload all in one drive link.
Oh, okay, sounds good.
Yeah.
మేడం ఇంకొక డౌట్, అది అసైన్మెంట్స్ లో పైన వీక్ అన్ని కంప్లీట్ చేశాను, అసిక్ వీఎల్ఎస్ఐ ఫండమెంటల్స్.
Mm-hmm.
ఈ వీక్ డిజిటల్ ఎలక్ట్రానిక్స్ లో 5 అసైన్మెంట్స్ ఉన్నాయి కదా మేడం, అంటే
5
5
కాదు,
అటెంప్ట్ చేయాలి.
ఫస్ట్ ఒక్కటి
ఓకే
చేయాలి.
ఓకే
ఒక్కొక్క
మేడం, అదే
వీక్కి
డౌట్ వచ్చింది.
ఒక్కొక్కటి.
ఓకే
ఓకే
మేడం.
ఓకే ఓకే.
So, ma'am, you have to do all 5 of the assignments of digital electronics, right?
Not 5 now. Every week one.
No, for this digital electronics today, the test there were like five sections.
Not all 5 sections. Every weekend one section.
No, I'm saying in the digital electronics test which was given for this week, there were like five sections in that test. So we have to do all 5 or
That's what I am telling. Not all 5. Every
okay.
week one test. How you will do all 5 without learning anything? Till now you haven't learned anything. From tomorrow onwards, actual sessions are going to start. As of now, just attempt 1 in digital electronics. Okay, everyone understood?
ఓకే
Yes, ma'am.
మేడం.
Okay then. Yeah.
Bye, ma'am.